Hola Ignacio,
Hola, Anand.
¿cómo estás?
Muy bien, aquí en Pittsburgh.
It's a pleasure to have you here today. So, today my guest is Ignacio Grossmann. He's the R.R. Dean University Professor in the Department of Chemical Engineering and former department head at Carnegie Mellon University. He's a member and former director of the Center for Advanced Process Decision Making, an industrial consortium that involves about 20 petroleum, chemical engineering, and software companies. He's a member of the National Academy of Engineering and fellow of AIChE and Informs. He has received the Informs Computing Society Prize and the following AIChE awards: Computing Chemical Engineering, William H. Walker for Excellence in Publications, Warren Lewis for Excellence in Education, Research Excellence in Sustainable Engineering, and Founders Award for Outstanding Contributions to the Field of Chemical Engineering. In 2015, he was the first recipient of the Sargent Medal by the IChemE. Ignacio has honorary doctorates from several universities in countries like Finland, Slovenia, Germany, Russia, and Spain. In 2008, he was considered by AIChE as one of the top 100 chemical engineers of the modern era. He has authored more than 700 papers, the recent textbook Advanced Optimization for Process Systems Engineering, and the textbook Systematic Methods of Chemical Process Design, which he co-authored with Larry Biegler and Art Westerberg. He has also organized the Virtual Library on Process Systems Engineering. Ignacio has graduated 68 Ph.D. and 34 master's students. His main research interests are in the areas of discrete continuous optimization, optimal synthesis and planning of chemical process and energy systems, and supply chain optimization. Ignacio, you were a legend in various fields. And as I said in the beginning, it's a pleasure, it's a great honor to have you here today.
Well, thank you, Anand, for a very kind introduction, and I'm very happy to participate, in this interview, this program. Okay, thank you. Thank you very
Excellent.
much.
So let's start. So, Ignacio, you were born in 1949 in Mexico. Where specifically?
Yeah, I was born in Mexico City, and the reason there, my parents are originally from Switzerland. They had moved from Switzerland, so at any rate, so I was born in Mexico City. Yeah.
Uh-huh. Your family background is very interesting. Could you talk a bit about it?
Yes, again, as I mentioned briefly, my parents were originally from Switzerland. My mother came from, Switzerland, St. Gallen. My father, the story there is a little bit more complicated in the sense that his mother was actually born in Mexico. And the reason for that, the family, Chapeau Rouge, was from the French part of Switzerland, Geneva. And a lot of French people moved to Mexico because of the Emperor Maximilian. So that's why she was born in Mexico. She went back after the revolution broke out. In any rate, when she went back to Europe and got married to my grandfather, they actually moved to Germany, to Frankfurt, because my grandfather became director of a hospital. And the thing that was interesting, she would actually speak some Spanish to the children, because again, she had lived up to 17 years old in Mexico. And that sort of sparked interest after the war was over. My father went to Switzerland, met my mother, and a Swiss company named Sulzer was going to open a factory in Mexico, and that's how they ended up being in Mexico. So that's a little bit the story.
Wow. Yeah. And do you speak German?
Yeah. I mean, I was actually my first mother tongue, so to speak, was Swiss German, as they call it, Schweizerdeutsch. But my father used to speak more the Hochdeutsch, the German. So I was brought up with both, and then I actually also went to the German school up to third grade, where we spoke both Spanish and German, of course. So yeah, so I do speak some German, and I do have relatives back both in Switzerland and Germany. So when I go there, I do speak to them in German. Yeah.
Yeah. Great. And how was life in Mexico City during the 50s and 60s?
I think in many ways, I think it was a very pleasant life. Mexico City was not as large as it is now. At the time, was about 5 million people. Mexico City was still a large city. Today, it's actually over 20 million. And I would say I have really very, very nice memories of my upbringing in Mexico City. And because of the French influence in the center of Mexico City, there's like an avenue called Reforma, which resembles a little bit the Champs-Élysées in Paris, if you wish. So there's a little bit that type of French influence. And so again, it was by and large, I do have again nice memories of my upbringing in Mexico City.
Mm-hmm. It seems that you used to collect stamps, right?
Yeah. I mean, I would say that was one hobby because, again, of my international connections, I like to get, stamps from Switzerland, Germany, and then, of course, also from Mexico. But it turns out I would say the one who really took that over in a serious way is my brother. My brother actually became a member of the Philatelic International Society, very much into the business of collecting stamps. I did not go that far, but yeah, it was definitely a hobby I did enjoy very much.
Uh-huh. Do you have only one brother?
I have one brother and one sister, yeah. And both of them, they still live in Mexico, yeah.
Uh-huh. Did they become scholars like you?
No, my brother, when he studied business administration, so, he went more on the business side. And my sister was basically, doing more like organizational. There's an interesting thing about my sister. There's something in Mexico called in Spanish Carrera Panamericana. That's the Pan American, the racing thing that they have in Mexico City. So her husband has been involved in that. So that's what she has been working on for many years now.
Okay. So were you involved in any sports activity?
Well, I did like to play soccer because, of course, in Mexico that was maybe the most popular game, and I followed the soccer league. So I did play especially soccer. There was a little bit of baseball, but I didn't play that much. But yeah, so it was mostly football, soccer that I played. Yeah.
Yeah, and speaking about soccer, what are your memories from the 1970 World Cup in Mexico?
Well, I definitely very much remember the final, Brazil-Italy. Brazil beat Italy 4-1, and of course at that time Pelé, which I'm sure you relate to,
Yeah.
was the major play by Brazil. So yeah, I did. It was very nice to have the World Cup at the time in Mexico.
Uh-huh. And which soccer team do you support, and what is your favorite Mexican player of all time? Mine is Jorge Campos.
Yeah. Well, that's today. I have to realize that in my case, that was when I was, a kid in Mexico City. So my favorite team was Guadalajara. Guadalajara is a city in Mexico. There was especially one player, Salvador Reyes. They called him Chavo Reyes. He was really a fantastic player, and so he was sort of my role model again in terms of soccer game. Yeah.
Okay. Yeah, I like Jorge Campos because he would dress in a very flamboyant way, and he was very short for a goalkeeper. Sometimes he'll just do crazy things, and then as a kid, I enjoyed very much seeing him playing. Yeah.
Right.
So in Brazil, one of the first things that come to mind when you think about Mexico is the TV show El Chavo del Ocho. It was, and it still is, a very popular show in Brazil. My favorite character is Don Ramon. Did you enjoy watching that show or any others associated with Chespirito?
Yeah, well, I have to tell you, in fact, Chespirito in many ways was the predecessor of Chavo del Ocho. Chavo del Ocho was a bit later from Chespirito, but no, it was a lot of fun to watch him on the TV. I think it was usually on Sundays where he had the show, so obviously I would not miss any of his shows. So it was a lot of fun. Really enjoyed them.
Yeah, it's incredibly popular, that show, and Chapulín Colorado also.
Oh yeah, Chapulín Colorado.
Yeah, it's super popular here in Brazil. You told me that you studied in a German school up to the third grade, and then you changed to an American one. How beneficial was it for you to study in these international schools?
Well, it was certainly interesting in a sense, very different systems. You have to keep in mind the German school was for boys and girls. It was called Alexander von Humboldt. Humboldt was a major figure in the Americas from Germany. And so it was a nice experience to be there at the German school. When I went to the American school, that was run by priest from Minnesota, and Benedictine priest, and that was only boys. not boys and girls, only boys. It was quite a different system. I would say in both schools, especially I have to say in the American school, the discipline was, very strict. So we had to, there was not much room for fooling around or anything like that. So you had to follow the rules. So, but no, it was, for me, it was interesting when I had to switch from, German to English, because I remember when one of the first days in the American school, they were reading a story and they asked me for, to read part of the story. And again, I had almost no English at the time. And for the first time in my life, I met the word potatoes. And since I didn't know how to pronounce it, I pronounced it potatoes. And everybody, of course, was laughing because, of course, that's not the way you pronounce it. But so it was a nice experience. Again, being in both systems.
Uh-huh. Yeah, in your defense, come on, potato. Yeah.
Right.
Yeah. So, how did you develop your interest in math?
I would say math was actually, you see, in that school, in the secondary school, we had a very, very nice teacher, and I still remember he was very passionate about math, and that's where we learned about the Pythagoras theorem, for example. And that actually then started to spark my interest in the history of mathematics. So actually, even up to date, I have several books I like to follow, books on history of mathematics. So, for me, it's both, mathematics per se, but then also history of mathematicians that I find truly fascinating, because they were all, amazing characters, as I mentioned before, Pythagoras, and you go back, for example, to people like Newton, Leibniz, Euler, and so forth. So, and then more recently, Erdős, for example, a Hungarian mathematician. So were all fascinating to me in many ways. Yeah.
Right. So your interest went beyond the subject itself, but you also took interest in their stories.
Oh yeah, exactly.
Of the main figures that contributed to the field, right?
Right.
Mm-hmm. And why did you choose chemical engineering?
Well, it turns out that actually I did want to study mathematics when I was going to go to university, but my father told me, well, if you go to mathematics, what are you going to do? The best you can hope for is to be a teacher. So you really need to think of something else. And when I looked around, what I liked about chemical engineering was the fact that, it was also not only having, of course, some math, but also chemistry, physics, and it was a very broad subject. And the other thing that I also learned at the time was that chemical engineers, at least in Mexico, used to have sort of fairly prominent positions in companies. So that's what kind of sparked my interest. That I thought, well, since it doesn't look like I may be able to study only math, then at least I'll compromise with, chemical engineering. And it was definitely, I think, in retrospect, a good decision. Although I do have to admit, in retrospect, I was fortunate that in many ways to go back to math one way or the other, through my Ph.D. studies. Yeah.
Mm-hmm. Now, Ignacio, I know you studied at the Universidad Iberoamericana, also known as Ibero, but you almost went to the Universidad Autónoma.
Yeah. So basically, at least at the time, Universidad Nacional del Litoral, as it was called, UNAM, was the largest university. I think even at my time, there were over 50,000 students at that university. But then, something very unfortunate happened in 1968. There was a very awful, situation in Tlatelolco. Tlatelolco is a major place in Mexico City, and there was a demonstration against the government, and the government sent the military people. They killed, hundreds of people, especially young people. And because of that, then the UNAM organized a strike that actually lasted for about 9 months. So in my case, since, when I switched also from the German to the American school, I lost 1 year. I didn't want to lose one more year. So I decided to go to Universidad Iberoamericana. It was a private university run by Jesuits, but in retrospect, I think it was a wonderful decision, because I think I got a really extremely strong and rich education at the Iberoamericana.
Yeah, so you had an excellent education at Ibero, as you said.
Yeah.
Do you find it comparable to the quality provided by the top universities in the US?
I do have to say yes. In fact, why am I saying this? Well, I was extremely fortunate that, for example, let's say, take the case of math. We had five courses on math, including algebra, basic math, one course on probability, one course on statistics, one course on numerical methods. So right off the bat there, it's almost eight courses, for example. But more than that, for example, my second course in calculus, we had this wonderful teacher, Professor Luis Vergara, who was very passionate about math. And our textbook was actually Tom Apostles, which is a very strong textbook in mathematics. And the one thing I remember the most, he was so passionate in one lecture, he told us, look, in the next lecture, we're going to cover the most important subject in mathematics, and that's the concept of limit. And I can tell you, if you don't master that concept of limit, you're not going to pass my course. And then when the lecturer came, he talked about the Weierstrass theorem, he talked about the limit. He was so passionate. So that, I think that really made a big impact on me, because you felt that there was something intellectually enriching that you could be very passionate of. So that was great. Then I had a second absolutely outstanding teacher. His name was Alejandro Purón de la Borbolla. And I was extremely lucky. He actually studied in Belgium, but he did not finish his Ph.D. because of the war. He had to return early. But I had with him, for example, something that at the time was amazing. In chemical engineering, there's a major textbook called Transport Phenomena, and the authors are Bird, Stewart, and Lightfoot from University of Wisconsin. At the time, that book was only out for maybe a few years. And to think that that book, for example, we use at the undergraduate level, that doesn't happen, for example, right here in the States. And in order to study that book, one of the things that you had to learn, for example, were tensor calculus. So I was actually exposed to tensor calculus, to fluid mechanics, Navier-Stokes equation. So it was really wonderful, the exposure that I had. And then to top it off, I had another wonderful professor, Professor Menabrito. He actually, at the time, again, from the University of Wisconsin, there was a professor named Dale Roth, and he wrote a book called Strategy for Process Engineering. And basically what that book covered was basically some basic concepts of optimization applied to chemical processes, including, for example, concepts like dynamic programming. So when I think back and I say, wow, I was exposed to all these really almost graduate level ideas, I could not ask for more. And then, of course, not only that, I mean, one thing that also made a big impact on me, you had to do a thesis as part of your undergraduate degree. And I was extremely fortunate because I was doing an internship at the Petroleum Institute, and that's where I met Julian Castellanos. He actually did his master's degree at the University of Birmingham in the UK. And what happened is that the topic of my thesis was a simulation of condensers of vapors with non-condensable gases. Okay, so it was a mixture of gases with non-condensable. And the thing is that the simulation involved solving two-point boundary value problems. So for that, I had to apply Runge-Kuttas methods for integration, but because these were, with boundary conditions, I used the Weckstein-Secant method for the conversion. So again, when I think back and say, wow, it was really extremely, extremely rich education, I think, that I received. And I really hate to say that, when I compare that, for example, with what we teach at the undergraduate level at Carnegie Mellon, I'm sorry, it's not, in many ways, not even close. I mean, of course, we also have to, in many ways, a good job here at Carnegie Mellon, don't take me wrong. But to think that I was able to be exposed to really, first-rate educators who were passionate about what they were teaching, and that they were really up to date. Because again, those books like Bird, Stewart, Lightfoot, again, had just come out. The same thing with Strategy for Process Engineering. So I thought I was extremely, extremely fortunate to have that education at Iberoamericana.
Wow. So you had world-class education in the late 60s and early 70s in Mexico.
Right.
Yeah, that's fantastic. In terms of OR, what topics did you learn during your undergrad? You already mentioned dynamic programming, but
Yeah, yeah. Yeah, well, again, of course, keep in mind this is chemical engineering, so at least it was, in terms of applied math, of course, there was also a lot of emphasis on things like linear algebra. During that course on strategy process engineering, I did get exposed also a little bit to linear programming, but we did not have, a course directly on that subject. What was also interesting is a course on, as I told you, I had one course on probability and one course on statistics. And that course in statistics was actually taught by an industrial engineer. So, of course, he gave a little bit of slant towards that area. So, but I did not really have, so to speak, let's call it a formal education in OR, right? So that was not the case. Yeah.
But did you learn about continuous optimization and?
Oh yes, yeah. I actually basic methods on optimization. Absolutely, one variable optimization type of methods, Fibonacci search and things of that sort. Yeah, absolutely.
Mm-hmm. You mentioned you had to write sort of a bachelor thesis, a tesina, they call it at times, right?
Yeah.
Did you have access to papers published in international journals, for example?
Well, on the one hand, of course, in the library at the university, there were, some journals, but then I was also very fortunate. I lived in the northern part of Mexico City, and that was very close to the Polytechnic Institute. And the Polytechnic Institute had actually a research center, which, by the way, they were heavily influenced by the French. So it was modeled after the French system. So in that research center, they had a very nice library. So I was able to access a number of articles there that, for example, one of the papers that I found there was who was going to be later on my PhD advisor, Sargent, as one example. I could find those type of journals. So it was, and again, since I took an interest already at the time in chemical engineering, also especially process systems engineering type of topics, it was wonderful to be able to access some of those journals at that institute. Yeah.
Mm-hmm. Very interesting. What influenced your decision to choose Imperial College in the UK for graduate school?
Yeah, well, it's interesting that you asked that question because I actually had three major possibilities that I considered. One was precisely University of Wisconsin because of Professor Dale Roth that he had written that book, so I thought that would be definitely interesting. There was also University of McMaster in Canada because they had developed the first process simulator. It was called at the time GMAX, so I thought, well, there could be an interesting possibility. And then, of course, I also learned about Imperial College through the a couple of papers I saw there. And at the end, I thought, well, it was interesting because they did make me an offer from Wisconsin, but then I was asked that if you get accepted, you have to do a teaching assistant and work so many hours per week. So I thought, well, so you have to do some work. But then in the case of the Imperial College, I did the application through the British Council. And for me, the other, honestly, the other motivation for going to London to Imperial College was because of my family connections. I thought, well, I'd be, fairly close to Switzerland and to Germany. So in that sense, I would be able also to visit my relatives. But I think in retrospect, it was definitely, the best decision I could have ever made.
Yeah, so you went there originally for a master's, right?
Yeah, oh yeah, exactly. That's the other thing. So at the time, when I applied to the British Council, my idea was to do a master's degree because it was the idea, if you did a PhD, that was an overkill for Mexico. So you don't want to do a PhD, what are you going to use it for? So I went with the idea of just doing a master's degree, but I was very fortunate in two ways. One, that my own PhD advisor, Professor Sargent, encouraged me to, continue to do a PhD. I did the master's degree in 1 year and 2 more years for the PhD. And I also had a very good friend who was actually German who also encouraged me. He said, look, you're already here. Why don't you take advantage of 2 more years and you're done with a PhD degree. So yeah, so that was definitely, again, also one of the best decisions that I could have taken. Yeah,
yeah, my grandfather, my mom's father, he did his master's at Imperial College in the early 50s, in between 52 and 53. And so,
right.
Yeah, so my mom lived in England for 1.5 years.
Okay.
And when did you leave Mexico to the UK?
Yeah, so basically I left 1974. So
74.
basically I finished my undergraduate degree 73, but then I had to do again the thesis. So I sort of defended, so to speak, my thesis. So actually what was interesting was not only writing a thesis, but you had an oral examination where you had to give a presentation, and there was a committee who would ask you questions. So that was maybe roughly about I think March or so of 74. And also at the time what I was doing, I was teaching part-time at the university, actually. Interesting enough, the course on math. So, but yeah, then I went to England. Was basically summer of 74.
Right.
And I stayed there until November 77.
37. Okay. So regarding Professor Roger Sargent, you once paid a very nice tribute to him by saying
Right.
that, quote, Professor Roger Sargent, founder and pioneer of process systems engineering, meant a lot to me. He had a tremendous impact on my career. I was truly fortunate and privileged for having him as my PhD advisor. He was a true inspiration, a visionary scholar with very high standards who believed in the power of mathematical optimization. He was a true gentleman and, above all, a very kind human being. End quote. Is there anything else you can say about him and his legacy?
Well, again, needless to say that I was extremely, extremely fortunate to have him as my PhD advisor. I should actually mention that one of the reasons, again, I selected Imperial College, he wrote a very visionary paper in 1967 in Chemical Engineering Progress. It was entitled Integrated Design and Optimization of Processes. And what that paper outlined was sort of a vision, how one could actually systematize, the design and operation of chemical processes through the use of optimization, process control. And actually, he also emphasized the collaboration with researchers in operations research. That was the first time that I, run into that term. And so I think he was definitely, well, he's considered to be the father of process systems engineering. Because again, the other thing that's interesting about him, if you look at his academic tree, I mean, it's really tremendous. I mean, a lot of the professors in the area of process systems engineering are somehow descendants of him, or belong to his tree. And again, the other thing that was interesting about him, which I was able to experience, was the fact that, again, although he was in chemical engineering, his heart really was in mathematical optimization. In fact, I was extremely fortunate that when I was a student of his, I was able to attend several meetings with people like Mike Powell, Roger Fletcher, really big names in the area of numerical optimization. Had been involved. So that was, and actually, I have to say, his heart was really in optimization. What was very interesting about him, when he did his PhD at Imperial College, it was all experimental about distillation columns. And I was really very surprised to see his PhD thesis in the sense it had not one equation. It had pictures of experimental equipment. And then, so what happened to him was very interesting. When he finished his PhD, he got a job in France with Air Liquide. And being in France, he started to read about, mathematics, and that's where he started to develop interest in mathematics. So when he returned to the UK, 4 or 5 years later, he got a position at Imperial College, and he devoted, all his efforts to mathematical optimization. It was truly an amazing transformation. And again, what was very interesting, again, with him was the fact that he, at the time, by the way, had developed an algorithm called Variable Metric Projection, VMP, for solving nonlinear programming problems. And VMP was really nothing else but the predecessor of the successive quadratic programming algorithm for nonlinear programming. So again, it was truly amazing to be exposed to somebody like him. And also I have to tell you a kind of a funny story with him. When I was a student, he was largely department head. So you usually meet with him after 5 o'clock in the afternoon, at which time, of course, he was already a bit tired. So when we had a meeting with him, if you didn't have something very interesting to tell him, he would almost start to fall asleep. But when you had something exciting, he would, really wake up and be very excited about it. So, but no, a wonderful human being. as I indicated, and again, very interesting that he was the major force within chemical engineering by bringing, really the area of process systems engineering where it is now. So he's truly a legend, needless to say.
Wow, that's fantastic to know. So, can we affirm that he was the one to start the conversation between chemical engineering and operations research?
Yeah, absolutely, absolutely. Yeah. I mean, to some extent, Dale Roth already started a little bit on that, so I also have to give credit to him. But I would say, as I told you, so with Roger Sargent, he would attend meetings on mathematical optimization with, David and Fletcher Powell. These were big names at the time in nonlinear optimization, and so he definitely. Yeah, I would say maybe in that sense, maybe more than OR per se, because we had, as you know, the Imperial College also has a very strong business school, and there was of course also some collaboration with them. But his heart was really, I would say, nonlinear optimization, and in particular, nonlinear programming. That was his, major, area that he worked on.
Right. Um, as a graduate student, you worked on three important problems, which respectively involve the optimal design of heat exchanger networks, multipurpose chemical plants, and chemical plants with uncertain parameters. Could you briefly talk about your main contributions to such problems?
Yeah, well, first of all, the problem of synthesis of heat exchanger networks, I like to call it, this is like the traveling salesman problem for chemical engineers. In other words, it's the challenge problem that everybody has tried different approaches, different methods on how to solve it. And at the time when I was a PhD student, that area just started to develop. And again, interesting enough, going back to Professor Dale Roth at Wisconsin, he was also one of the prime contributors to the area. So I think the important, what we did there was to try, you see, you have to realize at the time, we're talking 75, 76, there was no mixed integer nonlinear programming. So what I did for that area was actually to formulate the problem through an implicit enumeration scheme that was based on integer nonlinear programming. And again, with the using VMP, variable metric projection, as the NLP solver for that. So that was, I think, quite unique. Then the second area that I worked on was multipurpose chemical plants. And that was motivated to a large extent because we had the visit of Professor David Trippin from the ETH in Zurich in Switzerland. And they were, because of the pharmaceutical industry in Switzerland, they were very much interested in batch processing. So he had actually formulated a problem where I got really interested because there were two things. One, he was using some max operators. I thought, well, this is non-differentiable. So of course, if you use NLP, that's going to give you some trouble. But more than that, what really I found fascinating was that problem mathematically, it was really a geometric programming problem. In other words, you had polynomials where you could actually apply exponential transformations and convexify the problem. So that NLP could actually be reformulated as a convex NLP and therefore guarantee that you got a unique solution. And then the last area, the one on uncertainty and flexibility, came about from the fact that I had interest in how to deal with uncertainty, and really without knowing it, the work I did, at least conceptually, was very close to robust optimization. So in other words, how do you guarantee that constraints are satisfied over a given specified domain of the uncertain parameters, and this was done basically by maximizing each constraint individually. And we were exploiting at the time one of the equations to simply be able to determine the worst case for each constraint. In that way, determine a priori the potential worst case point. So that those were. I would say especially that problem later on, when I came here to Carnegie Mellon, expanded into the area of process flexibility. And so in many ways, what I did in my PhD, my PhD work was also, later on the foundation of research work. And I would say especially that third area, process uncertainty, led into what we call process flexibility, which, is something that we have done a lot of work.
Very good. So Ignacio, you returned to Mexico in 1977. with the task of leading the optimization group at the Mexican Petroleum Institute and also teaching advanced graduate courses at Ibero. Nevertheless, you still found the time to keep doing relevant research work, which included the first mixed integer programming approaches for process synthesis and an efficient optimization strategy for phase and chemical equilibrium.
Right, yeah. So basically, when I went back to Mexico, because by the way, since I had this scholarship from the British Council, I was supposedly, required to go back at least for a year, and I had the connection, of course, with the Petroleum Institute, and then especially with my former advisor of my undergrad thesis, and I was very fortunate that I could work in different areas. One interesting fact is that when I did my PhD, often with Roger Sargent, we would talk about the need for mixed integer programming, but I never got my hands on a mixed integer programming code, and that was not until I was in the Petroleum Institute in Mexico City. There was at the time a code called FMPS from UNIVAC. So I was able to access that code in MILP, mixed integer linear programming, which we use, for example, to model the selection of processes in integrated networks. So that was one of the first applications. Then the work that you mentioned on phase equilibrium, the thing that was interesting there was that the partial derivative of the Gibbs free energy, because you minimize Gibbs free energy for the equilibrium, when you take the partial derivative is the chemical potential, and what's very nice is that you can get explicitly the derivative analytically without doing any numerical perturbation. So those were nice properties. So I was very fortunate that when I was at the Petroleum Institute, I was able to do some work, and actually two of those works we actually ended up publishing. We submitted them for publication.
Yeah, you mentioned UNIVAC. So you were using punch cards.
Yeah, exactly. That was So even for my PhD work, same thing. And then of course also when I was at the Petroleum Institute, that was the time of the punch cards. You would take a box and to the computing center, and if you were lucky, you would have the answer back maybe in a few hours. Sometimes you had to wait a full day to get the listing of the output. And of course, you had to be extremely careful, because if you made a mistake in the syntax, you don't want to lose one day just because of the silly mistake in the syntax. Yeah.
Yeah. Did you learn how to code in Fortran in the UK or in Mexico before?
I actually, that's a very good point. Actually, already at Iberoamericana, we did have actually also a course in computing, and we did learn Fortran there. So Fortran was my, computer language that I learned at the university, and I applied that for my bachelor's thesis, and of course, we use also Fortran for my PhD work in the UK. Yeah.
I see. In 1979, you left Mexico to join CMU. How did that happen?
Yeah, that happened because Professor Art Westerberg at the time was at Carnegie Mellon, and he was on sabbatical in the UK at the University of Cambridge, because with Professor Hutchinson, they were actually writing a textbook on process simulation. And there was a meeting of the Institution of Chemical Engineers. So that's where I met him in person. And so what happened is that when I went back to Mexico, we kept track of each other, but basically he then contacted me and told me, Ignacio, we have an opening. Would you be interested in coming here to interview to Carnegie Mellon? So I thought, well, of course it would be interesting, because especially at the time, you have to realize it was Art Westerberg. There was also another professor it turns out to be, he was a student of Dale Roth. It was Professor Gary Powers. So there was a lot of emphasis at the time also on process systems. So it was truly unique opportunity. So that I decided to come here for the interview, and fortunately, shortly thereafter, they came back to me and made me the offer. This was roughly maybe June, July. Had to wait until February of the following year to have the 1 year stay that was required by the British Council. Yeah.
I see. I know you have a couple of anecdotes related to your interview at Carnegie Mellon.
Oh yeah, yeah. Well, yeah. The interesting thing is when I had the interview at Carnegie Mellon, because I was sort of more used to the British system, so to speak, where you went straight to the point. You didn't spend too much time on motivation and introduction. So my first slide already had, the formulation of with equations of a nonlinear programming problem, and this was a time when we used transparencies. Okay, and so later on, I found out that this was a professor who had been there several years before me, who told me, by the way, you should know that when you came to interview, people were really a little puzzled, saying, well, does he really know how to communicate? Because he starts immediately with equations going into that level of detail. But again, that was kind of the way we did things in the UK at Imperial College, go straight to the point, not using so much, introduction and motivation. So for me, it was interesting that despite the fact that I, really started with being very mathematical, they still made me the offer. The other thing that's interesting about my offer from Carnegie Mellon, apparently, what happened, some other professors were concerned by the fact that I was only interviewing Carnegie Mellon. They said, well, could it be that maybe there's no other university that's interested in him? Is it only us who are interested in him? And this is now a cultural type of thing, which is, at least for Mexican standards at the time, it would not look good if you told other people, look, I'm interviewing with other universities, because that would seem like you're not being loyal. So I would never say that in the first place. But for me, it was very clear that Carnegie Mellon was the place. I was absolutely not even going to consider any other place. So, well, but at the end, it worked out fortunately well. So here I am after more
Mhm.
than 40 years of that. Yeah.
Yeah. And tell me about your relationship with Egon Balish and his influence on you.
Oh yes, yeah. That's yeah. I do have to say. So when I came to visit Carnegie Mellon, I had also contacted Roger Sargent, and he told me about the great work of Professor Egon Balish. So I had the opportunity of briefly meeting with him, but he was truly an inspiration. So after I joined Carnegie Mellon, I actually sat into his course on integer programming. I still have his notes in my office, because they have a lot of fun memories of that course from him, because he was truly outstanding. I mean, he had very high standards, and always aiming very high. That's where I learned, of course, about relaxations, coding planes, polyhedral theory, and so forth. So it was wonderful to have access to somebody like him. I don't know if you know that Carnegie Mellon, there's no operations research or industrial engineering department. We have the business school. The business school is well known for being very quantitatively oriented. So the business school at Carnegie Mellon has two major subgroups. One is the one operations research, and these would be the integer programming, people like Egon Ballas, Gerard Cornjules, then also later John Hooker, and then also operations management, for example, Professors Rita Tayur in the area of supply chain optimization. So it was for me wonderful to have that link, because actually the other thing that happened through that is that my students would actually take courses with him, especially, for example, with Professor Egon Ballas. As a matter of fact, one interesting story about Egon Ballas is that he was also very impressed, fortunately, by our students. So after a number of years, he actually requested to have an adjunct position in chemical engineering. Why? Because he said, look, I've had all these wonderful students from chemical engineering in my course, so I would really like to have that relationship, being more formalized. So he actually would teach a course on disjunctive programming in chemical engineering in the last few years and of his life. So that was a wonderful experience with him. And again, also was very fortunate that with him we had some discussion with some of my PhD students where we were looking at, so for example, some reformulations of disjunctive programming problems. We actually developed something that we call later on generalized disjunctive programming, which was basically doing two things. One, introducing Boolean variables, so you can also add logic to disjunctive programming, but then also that the function could be, nonlinear. convex or even non-convex. So we had some very, very nice discussions with him with that. So so he, for me, he was actually, he made such a big impact on me that my website, my research website, the the HTM is egon.chemie.cmu.edu. Egon for his first name, because for Egon Ballas in his honor.
Wow, that's a very nice way to pay tribute to one of the most important personalities in the history of war, right? So
Right, right,
yeah,
right,
that's
right, right.
that's great. In those days, there were some researchers who were quite reluctant to the idea of using mathematical optimization, in particular integer programming, to solve process systems engineering problems, right?
Yeah, exactly. Yeah. So basically, what happens is that at the time, we're talking here now, what, 79, 80 or so, or early 80s. It is true that, for example, the optimization software was nowhere near what is now, for example, especially, say, mixed integer linear programming. And so there was a lot of resistance of people. I knew we actually had one such case, had one such paper that actually got rejected because one of the reviewers said, well, the authors are proposing mixed integer linear programming, which, we know it's very inefficient for solving. So one would be much better off using some heuristics or using some other type of procedure. So there was a lot of resistance to that idea, especially in the area of heat exchanger networks. There was a professor who actually did his PhD at Leeds in the UK. He was actually German, and he was advocating what was called at the time pinch technology, pinch analysis. The idea was to use main arguments based on thermodynamics using graphical representations to solve those problems. And we came here again, no, we can formulate a superstructure and formulate the problem as a mixed integer nonlinear programming, and then systematically. So we had a lot of discussion along those lines. So yeah, it was definitely not, at least at the beginning of my career, there was definitely a lot of resistance. There's one, well, two stories I can tell you along those lines that will give you an idea. In my stay at Mexico City, so since I had access to that MILP code from UNIVAC, the FMPS, we wrote that article, and we also then used that to write the outline for synthesizing chemical processes, saying, look, we could use mixed integer programming to optimize processes. And so, that paper was published as part of that work. Well, to my surprise, there was then a meeting called Foundation of Computer Aided Design, okay? And one of the keynote speakers had a presentation where the title was Process Synthesis, a Utopia in Mathematical Programming or an Adventure in Heuristics. That was the title of the talk. And then when he gave a talk, the initial part was actually all taken from my paper that we had written. The way you approach these problems, you develop a superstructure representations of a graph theory representation, then formulated, introduce discrete continuous variables, formulated as a mixed integer optimization problem. So he reached up to that point, but then he said, well, what is the problem with that? The problem, we don't know how to solve these problems. So what's the point? Why waste our time? So I was really, so you can imagine, I was just almost starting my academic career to hear somebody, that prominent about that type of critique. Very fortunately, both my PhD advisor, Roger Sargent, was there, and so was actually a professor from MIT, Larry Evans. So there was they debated to, the speaker, well, what the statement that you made is maybe not exactly true. There's still scope for that type of approach. But in many ways, it was also motivation for us to try to see, well, can we prove him to be wrong? In the sense of, yes, eventually we'll be able to address these problems through mixed integer optimization, through mathematical programming. And I'm very happy to say that after almost 40 years, definitely the answer is yes. There's projects, for example, the Department of Energy, National Energy Technology Lab, that are based especially on this whole idea of optimizing superstructures using both mixed integer, nonlinear, and generalized disjunctive programming. So so it was interesting. Another story I have to tell that's also interesting to tell you because it's related to Roger Sargent. So because Roger Sargent had also a background on process control, so they wrote a paper called for process scheduling for batch processes, and the idea here was that you could model those problems with something called the state task network. It was sort of a special graph type of representation, but the whole idea was to formulate it in a way like a quote optimal control type of problems, but using mixed integer linear programming. So that paper, the state task network paper, was submitted for publication first, and it got rejected. Again, same argument that was used. Say, well, are you kidding me? For scheduling, we want to solve real problems, not toy problems. So this is no use. It was submitted for a second time, got again rejected. It was finally accepted for the third time. We're talking, this was maybe something like late 80s. And in this paper, the state task network that is based on mixed integer linear programming, which is a unique paper, is one of the most highly cited papers in chemical engineering. But it's very interesting to see what it took to overcome that perception that approaching problems through mixed integer programming was basically a lost cause. And I'm happy to say that, they were all proved to be wrong, right? Yeah.
Yeah, these stories that you're sharing are just amazing. It also shows that when you have a sort of a disruptive idea, sometimes the community might not accept it right away, and you have to be patient, resilient to find your way through the reviewers and so on. Did you have the chance to speak with that person after that event in the early 80s?
Well, after the presentation, he approached me, kind of almost apologizing a little bit, but he said, look, that's the thing, it's very clear that you like math. Maybe what you should do is to do research in process control, not in, process, because in control you can maybe apply your mathematical techniques. But so that was, but again, very fortunately, things the way they have developed these days, it is an accepted approach to use mixed integer optimization. And it's also interesting, one point that I should maybe also emphasize. If you look within chemical engineering, there's quite a few researchers who have really contributed to the area of optimization. So for example, we're very lucky at Carnegie Mellon. My colleague, Professor Larry Biegler, he's developed, for example, IPOPT. IPOPT is interior point method for nonlinear optimization. And IPOPT, by the way, that paper has also a huge number of citations, I think, in SIAM Journal. His Andreas Victor is actually in OR at Northwestern University. Then, for example, Nick Sakinidis, he developed a code called Baron for global optimization. And again, that's going to come to show. But it's not only them. There's been also a number of other researchers within. One of the reasons I think this has happened is that in that sense, the chemical industry or even petroleum industry has always been interested in applying optimization. It's maybe no coincidence that you may, relate to the names of Charles and Cooper. Charles and Cooper were here at Carnegie Mellon, at the time was called Carnegie Institute of Technology. And one of the first applications that they did for linear programming was supply them for refinery planning of Gulf oil. Gulf Oil at the time was an oil company based here in Pittsburgh because oil was developed relatively close to here in a place called Oil City. So they were among the first ones to apply, for example, optimization to those type of problems. But then it also became very clear that companies, were definitely open and interested in optimization because they saw a value in that. So I had, for example, the people I knew at the ExxonMobil. I remember one of them, for example, was developing a successor of successive quadratic programming, except that we're not using the Hessian of the Lagrangian, which is a Hessian of the function, just as an example. But again, come to show, you also mentioned, for example, our Center for Advanced Process Decision Making. And, the companies that we have there is largely because they do have an interest in optimization. A very good example are industrial gases. The companies like Linde, Air Liquide, Air Products, logistics is a very important part of their business. So they value optimization. So we've been very fortunate within chemical engineering to have that, communication, if you wish, with optimization. In fact, for us, often we have a little bit the following dilemma when we, write a paper and we say, well, where should we submit it? Should we submit it to an OR optimization journal, or should we submit it to a chemical engineering journal? And usually it depends, of course, if the emphasis is more on the application, then of course we'll go to the chemical engineering journal. But if not, we'll definitely also submit it to a math programming type of journal.
Yeah. Yeah, it's a great synergy between the fields, and you benefited a lot from that as one of the pioneers. Ignacio, would you like to comment on your main methodological contributions related to mixed integer nonlinear programming problems, including, for example, those involving outer-approximation algorithms and generalized disjunctive programming?
Yeah. So again, you see, what's interesting is that on the one hand, the motivation came from the fact that we wanted to solve, engineering problems that were clearly nonlinear optimization that involved discrete variables. And I was extremely fortunate to have had a very bright student, Marco Duran, at the time. So when he started to do his PhD work, I still remember with him having the discussions on what later on became as the outer-approximation methods for mixed integer nonlinear programming. In fact, what's interesting, that paper that we wrote took actually, we submitted it to mathematical programming. From the time we submitted until it was accepted, it took 3 years. So actually, the reviews took a long time. There was a little bit of, maybe it was our engineering type of slant that did not fit exactly with the one of math programming. But I would say I'm extremely, extremely happy with what we accomplished with the outer approximation method, because it's recognized, of course, as one of the major methods for mixed integer nonlinear programming, and in particular when you have convex optimization problems for which, or convex relaxations, to be more precise, so you can guarantee global optimality. Then the other area that you mentioned, generalized disjunctive programming, that came about because of we had a very nice sort of research effort in engineering design that was multidisciplinary. And as part of that, Professor John Hooker was part of that, and he was very much interested in logic. So again, I had also a very bright student at the time, Ramesh Raman, and so we had a lot of discussions and on how to incorporate logic in these mixed integer problems, and that then led us to this idea of using a high level of representation, where rather than requiring that we write explicitly an algebraic objective function and algebraic constraints, equality and inequality constraints, that we write problems where we allow, first of all, Boolean variables. And through Boolean variables, we could then have as constraint logic propositions. We didn't have to write them immediately as algebraic 0-1 constraints, but you could represent them as logic propositions. And then for the equations, we allowed the use of the disjunctions, where the argument of the disjunction was an equation. So we had like an indicator variable. If the indicator variable is true, then you apply the equation. Otherwise, it's false. And that whole concept of generalized disjunctive programming, again, was definitely very much inspired by the pioneering work of Professor Egon Ballas. Mm-hmm. He actually, I don't know if you know, but he did write a very nice book at the end of his career on disjunctive programming, a really beautiful piece of work. But that was truly an inspiration. But you see, what's interesting is, so on the one hand, we were, of course, interested in the math optimization part of these problems, but they were driven by the need to solve these engineering problems. You see, because, for example, with generalized disjunctive programming, the big advantage that we had was the following, So when you postulate a superstructure, you say, well, here are some possible units, and I'm going to interconnect them, but they are nonlinear input-output relationship. And the problem is that when the flows go to zero, okay, the equations can become singular. You see, that doesn't happen if you have a linear problem. If you have a linear problem and the flows go to zero, it's no problem because you have a constant matrix of coefficients. But with nonlinear optimization, when flows go to zero, the equations become singular. And GDP, generalized disjunctive programming, was a very nice and elegant way of avoiding that, because what we would do, we would iterate by saying, fix your binary variables. Anything that doesn't apply, remove it from your formulation, and you end up with a reduced nonlinear optimization problem that is well defined. It's devoid of all these non-singularities, and then we could still build a master problem based on linear approximation based on that problem. So it was still very much inspired by Outer-approximation. In fact, for GDP, we've actually developed a code. By the way, talking, maybe I think I know you're going to also ask me about some computer codes, but let me just mention that as well. So with EMA, with Outer-approximation, we developed this computer code called DICOP. DICOP was maybe the first, at least commercial available MI-NLP solver that we made available through GAMS. There was a collaboration we had with the people at GAMS in Washington, because what's interesting about GAMS, they developed this modeling system at the World Bank, and for us, I was on sabbatical. I could now learn about that modeling system, so we were able to implement our MI-NLP method, in GAMS, and that is still available today. It stands for DICOP, discrete continuous optimizer. That's what it means. But then for the generalized disjunctive programming, that's a much more recent development. We have developed something called GDP Pyomo, Pyomo GDP, Pyomo.GDP. And what we do there, you can formulate the problem with this generalized disjunctive programming, and then you have the choice of various ways of converting that problem. It could be converted to a mixed integer problem using big M, using whole reformulation, or it could also using a specific algorithm, like we called something logic-based Outer-approximation, that was avoiding, again, the need of solving these NLPs where things did not apply. So at any rate, so what I'm saying, very fortunately, the work that we have developed, again, has been inspired by these applications, but then, we're able to fortunately make them sufficiently general so they are also being used in other disciplines.
Yeah, GDP became a very powerful framework to address several mixed integer nonlinear programming problems arising in chemical engineering, right?
Exactly, yeah. Again, especially in these so-called superstructure optimization, because again, what I'm saying, if you pose a problem from the beginning in algebraic form, you run into the problem that if a module in the superstructure is not selected, the flows go to zero, and we have nonlinear input-output, and then the equations become singular, Jacobian becomes singular. Then you run into all kinds of numerical problems. But that problem can be avoided with GDP, because we're iterating by fixing the Boolean variables. In fixing the Boolean variables, we remove all the equations that are not needed, and we end up then solving just a reduced NLP that is well defined.
And I was about to ask you about your computational contributions on the topic, but you already highlighted some of them. And what about your work on flexibility analysis to address scenarios with uncertain parameters?
Yeah, no, that's a very good point. So you see, again, this actually goes back, as I indicated before, to my PhD work, where the third part had to deal with uncertainty. And I was also here extremely fortunate when I started to do my work here at Carnegie Mellon to have a PhD student. His name was Keshava Halimane. And conceptually, the problem was the following. How do you model a condition that states that you want to be feasible for inequalities, for fixed, say, stage one decisions, allowing for the possibility for recourse, and such that the constraints are always satisfied over a given domain. So it turns out that problem, with my student, we're able to formulate it as a max-min-max optimization problem. So basically, a problem that goes beyond robust optimization. In robust optimization, the classical one is simply, meeting the constraints over a given domain, given some stage one decisions, okay? Now, there's been lately in robust optimization the idea of, quote, adjustable robust optimization, where what they do, they also allow for some recourse variables, but the problem is that what they have to do, they postulate some linear functions that approximate these recourse functions, whereas we have the exact mathematical formulation. It's a max-min-max optimization problem. Now, so in that sense, it's been very, very nice to have that formalism, because it is a rigorous way of handling those type of problems. We've actually applied and developed algorithms to solve those problems. We've been able, for example, to show that the max-min-max problem can actually be formulated as a MI-NLP problem, as a single MI-NLP problem. And of course, depending on the nature of the functions, it may be convex or non-convex. But yeah, and also here I have to say, what's been the motivation? The motivation, again, because of all the industrial interactions we've had, it's very clear that industry is very interested in uncertainty, because of course they realize there's a lot of uncertainty in the data and so forth. So one of the things that we always try to convey to our colleagues from industry is the following: to say, okay, you want to solve a problem on the uncertainty, first and foremost, you need to have a robust and well-defined deterministic problem. If we cannot solve efficiently the deterministic problem, going that extra step to add the stochastic programming, whether it's two-stage or multi-stage, it's a major, computational expense that you're going to incur. So you better have a good, method for that. But then going back to flexibility, and since I just talked about stochastic programming, so stochastic programming, so usually you optimize the expected value of a cost subject to, constraints. And what we do in flexibility analysis is we add a constraint requiring that we also want to be feasible over a given domain. And that's very important in engineering, where, for example, you say, I want to make sure that my plant will work so that even if the specifications of the feed, for example, of the raw material change, I can still meet my production quota, or I can meet my production quality requirements. So that's been the work on flexibility. We actually, this is several years now. I had a very good student. His name is Qi Zhang, Qi Zhang. He's now professor at the University of Minnesota. And with him, and also a researcher from Portugal, we wrote this paper about the relationship of robust optimization, adjustable robust optimization, and optimization with flexibility analysis. And what came out to be very interesting is that for linear systems, the two are equivalent only for the case where you have a single uncertain parameter. If you have a single uncertain parameter, then both give you the same answer. But if you have two or more uncertain parameters, you actually get more conservative results going the via of the robust optimization, whereas the formalism through flexibility analysis actually gives you better answers, because it opens up, so to speak, the feasible region. Yeah, but I would say, I'm glad that you asked that question, because flexibility, again, is also very much of great interest, of great concern to people in industry, because they want to have the capability of coping, with changes, and so it has resonated very well. Yeah.
Mm-hmm. So you address uncertainty by adding constraints rather than optimizing over a bunch of scenarios.
Well, we do both. So we have done, strictly speaking, I have another very bright PhD student, San Lee, who's now at Purdue University. He's my relatively recent student. With him, for example, we developed algorithms for two-stage programming, nonlinear, with integer second stage variables and so forth, that complicates the problem, or for non-convex problems. So yeah, we've dealt with stochastic programming and such, but we've also dealt with stochastic programming with that additional constraint that we want to remain feasible over a given domain, allowing for the possibility that we may have recourse variables that may be adjusted depending on the realization. The idea is more or less like this. You fix a stage one decision. When the uncertainty is realized, what we're modeling is the idea that we have a recourse variable that we can adjust to respond to that change. And by responding to that change, we can then regain somehow feasibility. That's the main goal there. Yeah.
Right. Is it correct to say that flexibility analysis lies in between robust optimization and stochastic programming?
Well, I would say not quite, again, only in the following sense, that in flexibility analysis, the main concern is the feasibility. So it's the constraints, okay? So you could apply actually the flexibility analysis if you wanted to both robust and to stochastic programming as a constraint to both, okay? So because again, it just, think of it as just like a constraint you're adding to your problem. One other thing that we did in the area of flexibility, and that was also very well received, we developed a concept like flexibility index. In other words, can we measure how flexible is a given design? So for example, we would postulate expected deviations, and if the design had a flexibility index of 1, it meant we could meet exactly those expected deviations. If it was less than 1, it would be a fraction of that. If it was greater than 1, it would actually exceed that. And that approach, in a way, also has some relationship with chance-constrained optimization. In chance-constraint, you're actually working with distribution function of the parameters. In the case of the flexibility analysis, we're working really with the intervals of the parameters, typically with lower and upper bounds, although we can also accommodate, of course, other geometries. But yeah, it's basically specifying a set over which you want to guarantee feasibility. Yeah.
Right. Got it.
I actually, you actually a good point, because the area where it's actually more closely related is semi-infinite programming. It's semi-infinite programming. You want to optimize a problem subject to the constraint that you meet the constraints for all the points belonging to a given set. That mathematically is semi-infinite programming. And what we've done in a way is kind of extended semi-infinite programming by introducing these recourse variables, which then lead us not to the maximization of each constraint, but to the max, min, max. The max, min, max is the worst parameter value, such that for all the constraint, we meet the constraint for the worst case, if you wish. Yeah.
Yeah, because when you think about recourse, it's one can relate more to stochastic programming than to robust optimization, right? That's why I asked that question of.
Yeah.
Right. So let's talk about the applied side of your work. Many companies like ExxonMobil, DuPont, Mitsubishi, and so on have adopted the optimization strategies devised over the years by your research group at a Center for Advanced Process and Decision Making, right?
Yeah, right. Yeah, so basically, we've been very fortunate to have this center. It's been over 30 years, and it's on the one hand, we benefit from the fact that we get exposed to real-world problems. So we've been, for example, let's say in the area of oil business, how do you do well placement? Why do you decide to drill the wells to maximize the production of oil, as an example? If you're dealing with a chemical process, how do you operate that process, or what kind of reactor should you select to obtain, the minimum cost solution? Or then also we have problems that are a little bit more on the OR side. They're related to scheduling and planning. We say I have an existing plant here. How do I schedule the production? The scheduling problem, as I outlined briefly before. Or we also have actually supply chain type of problems, where actually, as part of the center, one of the subgroups that we have is called enterprise-wide optimization. And the whole idea of that effort is to do essentially supply chain optimization, but including the manufacturing part. And one of the recent interesting projects that we've had, this is with Dow Chemical, is sort of an integration of the supply chain with the material flows, we're taking from raw material to the distribution, but also with information flows. So we've actually modeled business processes where you get from some type of system, the orders that are coming in, you need to translate them into targets for production. And that whole problem, we've been able, the student, he just graduated actually last year, Hector Perez, did very nice work on integration of these different aspects for supply chain optimization, sort of like integrated. It was also called, quote, digital supply chain because it uses information flows with material flows. Yeah. So there's been a lot of problems like that we've been very fortunate to be exposed through our interactions with industry. And one of the things that we also do, which is also interesting in the center, we also write quite a few joint papers with them. So it's not only that they come give us a problem, we then do some solutions, but what we're looking for is a two-way street. On the one hand, to be exposed again to these interesting, challenging problems, but then not in all projects, but in many of them, we do involve PhD students. So they have to, of course, do a PhD thesis and do some original work that can be published. And so, and again, one recent example that I can quote, John Wasik, he was, at Dow Chemical, been really instrumental in the collaboration we had over the years. And I would say with him, we've written at least, 15, maybe even 20 joint papers. So, and that also speaks very highly, I would say, that's been the fortunate thing about the process industry, that they do believe in research. So they actually, encourage, and it's well viewed that they devote also some of their time to write publications and attend some professional meetings, like informed type of meetings, if you wish, to present this kind of work, just like chemical engineering meetings as well. Yeah. So that's been so again the present emphasis, I would say, is now moving a lot more into energy systems. We've had this initiative for energy systems, but now with a great concern on sustainability and things like decarbonization, circular economy. To give you an example, we have a really interesting project with Shell, major oil company, where the question that they're asking is to say, well, we have these oil refineries. How could you retrofit those refineries to decarbonize them? So that, for example, if you need hydrogen, is there a way of producing that hydrogen without, for example, burning natural gas? Okay. Or if you need, for example, steam, rather than raising steam again by, for example, burning natural gas, we're going to use electrification, electrified boilers. And so I would say that's been very, very interesting to see how these days the industry is also taking very seriously the challenge of, sustainability, because the industry, another really beautiful example, I think, is with the company Total, the French oil company. We started working with them on, again, problems that were related to oil production, okay, oil exploration and oil production. Since about 4 or 5 years now, we've been working on carbon capture and sequestration. So basically the problem is you have several locations where you're going to collect CO2 in liquefied form, then the logistics on how you transport that CO2 into some port, from which it will be injected to some wells that have been depleted to do sequestration of CO2. Okay, so again, it's just one example that the really nice thing is we would probably never have run into that problem if we were just reading some papers, but here now we have the great advantage of interacting with real people from industry who have to face these problems. So, and they're all very, challenging problems. And again, the idea at the end is that we will, produce publications out of that work.
Yeah, it has been a very fertile collaboration
Right.
between your group and the industry. And it's really encouraging to know that they are interested in also publishing papers and that they really care, they genuinely care about doing research work in a high level and provide not only the data, but also the efforts in when writing the papers. Ignacio, you have an extensive list of PhD students. Unfortunately, some of them who were really talented are no longer in this world. You mentioned Marco Duran and Ramesh. Would you like to pay a small tribute to them and also to comment about those who are still around?
Yeah, well, first of all, again, I've been extremely fortunate with my PhD students. I would say, if I think back on my career, I say, well, the biggest gift I have received, if you wish, is to have all these very motivated, highly talented students. And as you indicated, have 68 PhD students so far graduated, 34 master's students, and of the PhD students, 16 of them have actually gone to academic positions, and the others, of course, to industry. But talking about three of my former students who very, very unfortunately are no longer with us. First, it's Marco Duran. Again, he's the one who developed the Outer-approximation. Very unfortunately, I think it was a combination of a case of depression, I think, and at any rate, so we actually wrote a tribute to him in the journal Optimization and Engineering, the volume dedicated to Marco Duran, because he was working at ExxonMobil and had a really huge impact, and not only in some of the more, let's say, process type of problems, but also in catalysis and areas like that are a little bit outside from mainstream of process systems engineering. So first, again, Marco Duran. He was, by the way, originally also from Mexico, so it was also very nice to have a student from Mexico, originally with me. Then the second student I should mention is Professor Chris Flores. Chris Flores was a very, very bright student. He was oriented more towards application, did some outstanding work in the area of synthesis of heat exchanger network synthesis. He actually took a position at Princeton. They had the very prestigious Professor Lapidus, who was kind of assistant type of person. So Chris came in, they did a wonderful work. He actually then was offered a position at Texas A&M in their energy center. And again, unfortunately also Chris, just like Marco, he passed away mid-50s, a heart attack while he was in Greece. And I should also mention that Chris Flores was actually elected a member of the National Academy of Engineering, because he had a tremendous impact. He produced, again, lots of good work and, again, many bright students. And then the third one, Ramesh Raman, that you also mentioned before. Again, he was the one who really started to introduce the idea of disjunctive programming and logic-based optimization. And very unfortunately, again, he passed away while he was in India, where, he died of a cardiac arrest. So again, it was very sad, very shocking to hear about that. And again, needless to say, I remember them, of course, very fondly. I do keep in touch with their wives because, of course, they represent a lot to me. And what can I say? I mean, it's really sad to see that such, tremendously bright people, are no longer with us. Especially young ones, because I mean, they all died basically mid-50s. One particular example I have like to quote is Chris Flores. When Chris Flores was my PhD student, his father passed away when he was in Greece. His father was in Greece, and his father actually passed away also of a heart attack. And because of that, Chris felt the need to try to finish his PhD very quickly so he could help his mother and the family, because the father was no longer with him. But then it was sad to see that he followed pretty much the same fate as his father. Yeah. What can I say? Except hope they rest in peace and know that we greatly value and appreciate all the work that they did for us. And as people, they were wonderful people, wonderful persons.
Yeah, it's very sad that they left very early.
Yeah.
But you still have an army of former PhD students who are doing fantastic work all over the place, right?
Right. Yeah. So again, as I mentioned before, so I have 60 plus PhD students who've graduated, and again, a good number of them are also in academia. And so the nice thing that we've had, and I have to say this is also related to chemical engineering. If you look in chemical engineering departments, the major source of faculty members in this area of process systems engineering has been actually Carnegie Mellon. Not only students of mine, students of my colleague Larry Biegler, my colleague also Nick Sargent has been the same thing. And now we also have Carl Laird. He was a student of Larry, who's actually now joined the group. He's also had students who are placed in academia. So we're fortunate to have had this type of impact.
Right. So you're a great supplier for other universities, providing great alumni.
Yeah, right.
You were also quite known for your teaching and education efforts in the field of chemical engineering. Could you comment on those that you find more relevant?
Yeah, well, I would say at the undergraduate level, we teach at Carnegie Mellon a course on process design. That's a required course in chemical engineering. But what was really an inspiration there when I joined Carnegie Mellon was Art Westerberg was teaching that course. And it was, you see, very sadly, at many universities, the process design course is viewed as like, not very scientific type of course. So many professors don't even want to teach that course. But basically, what we've tried to do is just to say the opposite. I mean, there is a science base in process design, and that's what we're trying to teach to our students. So actually, as a result of that teaching of process design, that's what gave rise to the book on strategy for chemical processes design. Sorry, not strategy, chemical processes design textbook with Art Westerberg, Larry Biegler, and me. That's a reflection of what we teach at Carnegie Mellon. We're actually talking about doing an update of the book because now we want to especially introduce them more with issues related to sustainability, life cycle analysis, circular economy, and so forth. And that book, by the way, covers both undergraduate and graduate level. Okay, so at the undergraduate level, I would say what I've been very happy is to teach this course on process design. We've actually also produced, there's an organization called CASH, which is Chemical Engineering Education. And for that, we have actually produced modules. A very unique thing that we have at Carnegie Mellon, and this is thanks, I have to give credit to Professor Sirola, who's at Purdue University. He was in industry at Eastman Chemical for over 30 years. And lately, he's the one who's been supplying us with design problems that are truly unique. Okay, so for example, we had 2 years ago a project on carbon capture, the CO2, direct air capture, which is, a new technology that has been developed. We did, for example, last year, quote, blue hydrogen, where you produce hydrogen, minimizing the emissions of CO2 and so forth. So I think the students also get highly motivated when they see that they're working on design projects that are relevant. So I've been very, very pleased with that. And now we have Professor Ana Torres, who's actually taking over a course for me. I still continue collaborating there. But then the other course at the graduate level that for me has been, very meaningful. It's a course called Advanced Process Systems Engineering, Advanced PSE, we call it. And that course is basically one half is optimization and the other half is applications. And in that course, I've actually written as a book called Advanced Optimization for Process Systems Engineering. The Cambridge University Press was published in 2021. And again, covers all the topics related from basics of optimization, fundamental concepts of theory, optimality conditions, nonlinear, and then of course going into nonlinear, linear programming, then discrete optimization, symbolic logic, disjunctive programming, and then also decomposition methods like Lagrange decomposition, and then also stochastic programming, and then of course some of the applications that I just also talked about. So yeah, I'm extremely happy with teaching that course, and again especially happy that it has resulted in a textbook. That's one of the things being an academic, you probably know this, it's not easy to write a book because it requires a lot of effort. So my last book, I was able to write it largely because I was on a sabbatical leave and I was spent with a Fulbright program for 3 months in Argentina. So I was removed from here, and that gave me time to write I had already written, of course, a good part of the notes, and my secretary had helped me with that as well. But you really need it. You need to have that type of concentration to be able. It's not trivial to write textbooks because I think ultimately, if you write a textbook, that's it's going to have, of course, a big impact. It's going to be used and read by the students, and that's where you can have also a big impact for education. I think as academics, we have to realize that it's both. We're here, why? Because of two things, because of education and because of research. So we have to try to excel in both.
Yeah, fantastic to hear all of this. How long did it take for you to complete this last book of yours?
Well, again, that last book, I would say, over the years, I had written some notes that then started to be typed by my secretary at the time. So, I mean, that was at least maybe 8 year period, but it took basically that 1 year where I was able to concentrate and put everything together and write the draft of the text and so forth. I worked with Cambridge University Press. I found it to be extremely helpful. It was a very nice experience putting together that book. Yeah,
Yeah.
but yeah, yeah.
It's very time consuming. You have to care about a lot of details, especially notation
Oh
and
yeah,
other
yeah,
things,
yeah.
and to be
And then
consistent.
also the exercises. Exercises is the other very important thing. You need to write a book where you have meaningful exercises and you have solutions of them. Of course, I took advantage there of the fact that teaching the course, given the homework assignments and so forth, that's where I would take most of my exercises or from exams, right? Yeah, exam questions. Yeah,
Ignacio, we have to talk about your wife, Blanca.
yeah, right.
She has been incredibly supportive throughout all these years, right?
Absolutely, absolutely. I mean, well, what can I say? To begin with, I would say I could not think of a better mother for my children. Okay, and I really mean it because that's super important because that has meant that we're together as a united family. We're extremely fortunate that we have 3 children and we have now 6 grandchildren. We just got together for Thanksgiving, for the whole week. It was a wonderful experience. So for me, the family is also extremely important, and I think my wife has been, of course, extremely helpful and supportive. And especially, I have to admit, having to put up with a husband like me, who was working maybe a little bit too much. Okay, so I've tried now to compensate a little bit. Starting September the 1st, I've actually taken what is called phased retirement, meaning 50% of the time. So the first thing I did, I found the opportunity to spend 6 weeks in Spain. My wife is from Spain. She said, look, this is at least one way I can start to repay everything she's done for me. So we spent time in Spain, very close to where her family, so she can, be close to the family. And yeah, needless to say, as they say, behind every man there's a woman, and this is absolutely the case. I have to give her
Yeah.
tremendous credit for all. I would not have been able to accomplish what I have without her support. Absolutely,
Yeah.
absolutely, as simple as that.
That's great to hear. She was originally trained to be a nurse, right?
Yeah, exactly. Yeah, yeah, yeah. Yeah, so actually, she was, I met her in London because she had been a nurse and had worked in Switzerland for 3 years. And so when we came here to the US, initially we were debating would it be worth or not to work. She said, no, no, I think I better. We already had a daughter at the time. She was born in Mexico. Claudia is her name. And so she said, no, no, I really want to stay at home with them. And I think that was, a tremendous thing because knowing that the children, I have tremendous respect, I have to say, for couples where the two of them are, especially faculty members or professionals for that matter, because it's very difficult. How do you, pay all the attention to the children when they're growing up, especially in their initial phase? One thing I would always try to do whenever I came back home from work was to say, now, Blanca, you rest, I'm going to take now care of the children, play with them. I usually went to play, did all kinds of things with them as well. But needless to say, the major burden was on her, not on me. So, yeah.
Yeah. I mean, it's very nice that you recognize all her efforts and you have
Right.
been living very happily across many decades. Um, do you have any regrets in your life?
I mean, I don't think I have regrets in the sense. I mean, I don't think I could have been more fortunate in the sense, first of all, because of the family. I just told you. I mean, if I think of the children I have, the grandchildren, my wife, That's I think I'm truly blessed with that to begin with. And then my academic career, of course, same thing. I've been extremely fortunate to have had extremely bright students and highly motivated, and we've been very fortunate and lucky to be able to do innovative work and so forth. So that's in that sense. I don't say, when you ask me the question, do you have any regrets? Maybe the only regret I would have is the following. And in a way, it's gotten worse more over the last, say, 10, 15 years, which is that we spend so much time reading email and doing stuff like that, that, well, I would consider not to be very exciting and productive. But one of the side effects of that is that I happen to like to read books. I really like reading books. And a regret I have is that I wish I could have had more time to read those books. In particular, I think I told you I have actually a number of books, for example, History of Mathematicians. I love to read those books, not only on that, of course, on other topics as well. But I would say maybe my only regret is that I wish I could have had more time to read them, but maybe the only explanation I can give, and that's something that does worry me a little bit. I don't know how you feel about it, but with the modern world, there's a lot of things that we have to do now by ourselves, right? Again, we manage all hundreds of emails that come in. You have to reply to all of them. You have to organize your information. And I don't know how it is in Brazil, but for example, at least I have to admit here, unfortunately, at Carnegie Mellon, it was not the case as it was, say, 30 years ago, where we had, very strong secretarial support. Today is almost gone. So even I have to do copies, or even I have to do my travel expenses and stuff like that.
Yeah, I know,
So that's
I know the feeling.
yeah, exactly. So that's a big challenge for us, the academics these days. So, but I hope that despite some of those challenges, we can still, well, survive, so to speak.
Mhm. Ignacio, you have accomplished nearly everything one could possibly think in academia, including being listed in 2008 as one of the top 100 chemical engineers of the modern era. Where do you find the energy and motivation to continue doing relevant work?
Well, again, I would say it's the students. For example, let me tell you one thing that was extremely meaningful to me. Last year, when I taught the undergraduate design course, let me tell you the following anecdote. It's a course that is very time consuming because you teach them new material, they have to learn new techniques, and they have to work on a project and so forth. So the dean at the time sent me an email that went like this. He said, Ignacio, you have been identified as one of the professors who makes students work an excessive number of hours. What are you going to do about it? And I said, well, isn't learning important? I mean, I want to think we give our students a competitive advantage. And in any event, so the thing that to me was extremely satisfying is that every year in the graduation ceremony, they give several awards, and one award is for that the undergrad students give to what they consider to be the best teacher that they've had. It's a teaching award, and I received that award for having taught that course where they had to work very hard, but yet they recognized at least they learned something. And to me, that was so satisfying. It was really a tremendous reward for me to say, hey, at least it was worth the effort. And yes, they had to put in, of course, a lot of hours, and yes, we had to work very hard, but some interesting thing came out. And then at the end, the students, even by themselves, recognize that. So that was extremely satisfying. And same thing goes, of course, with the graduate students. When you, for example, when I had to recently was into a very interesting situation that two of my students got hired by the same department, same university, by Purdue University, chemical engineering, hired David Bernal and San Lee. And that's also very satisfying because you say, well, that means that very fortunately we're trying to promote here new ideas and especially try to keep standards of excellence, because I think that's at the end also very important, right? I mean,
Yeah. Uh, would you like to leave a final message for our viewers and listeners, especially the youngsters?
yeah. Well, again, thank you so much for giving me the opportunity for sharing, all my experiences, my ideas, and and the very kind, introduction that you've given to me, and quoted all these nice things. So I'm really humbled by that. And maybe I'd just like to finish with the following, especially for the young people. I think what is very important is, first of all, do not give up. You have to be persistent. You keep trying. Don't give up. But the other important thing there is also to dream. I think, you see, when I think back, maybe it sounds a little naive, but it was interesting to think that at some point in time, people say, mixed integer programming, are you kidding? That's you can't do that. Well, it was having that dream to say, no, yes, we can do it. So I think it's very important that we all have a dream, something we want to aim for, okay? And I think at the end, what this also translates is to having a passion. It's very important to be passionate. I'd like to quote here, actually, from the German philosopher Hegel, had this quote, this, nothing great has ever been accomplished without passion. So I think the key word is passion. I think if we keep that passion, and how do we keep it? We keep it, of course, with interest, trying to do our best, and maintaining, especially also, high standards of excellence. That's also something that I think, unfortunately, sometimes these days is not, valued as much, because it's considered to be, well, whatever, don't want to go into those details. But somehow, if you talk about academic excellence, some people say, well, that's not really our goal here. No, it is our goal. We want to strive for high goals. I would say that would be my main message to the young people. Please try to be passionate and try to keep the highest levels of excellence of your work, and you'll be rewarded for that. Okay. Again, thank you so much for giving me this opportunity to have this interview with you, Anna. Thank you.
Yeah.
Thank you very much.
Now, I'm the one who should thank you, not only for this fantastic conversation, but also for this great final message. I was inspired myself, and I'm sure the viewers and listeners will be also very much inspired. For me, it has been a great experience interacting with you. You were a legend, but you made me feel really comfortable. You were a really down-to-earth, soft-spoken person. And I understand now very clearly why the community, including your colleagues, students, they all adore you. So I just have to thank you. Muchas gracias, Ignacio. And I hope to, connect with you one of these days.
Thank you. And again, but one more last thing I also wanted to mention, which I really failed to mention. Of course, I acknowledge my students, but I've also been extremely fortunate to have had, postdoctoral students who were part of my group, and they also helped me to enrich our research very much. So again, thank you to all my former students, including my postdocs and collaborators. So it's really thanks to them that I've been able to accomplish what I have now. Okay. Yeah. Thank you very much.
Yeah, including one of them, Pedro Castro. He was the one who made a connection between us, so I'm really grateful. Right. He also gave me some information behind the scenes, so I could get that and also put in our script for this conversation. So it has been great. So Ignacio, if you want to visit Brazil, you know where to find me. So let's stay in touch. And I wish you all the best. Take care of your health. And I'm sure you're going to stay active for many years to come. So I'm looking forward to see your progress, your advances, and your contributions. Muchas gracias and hasta luego.
Hasta luego. Muchas gracias. Bye-bye. Ciao. Ciao.